All right, let's dive in. Today we're tackling maybe the single most notorious keyword in JavaScript.
Oh, yeah. It's
What?
definitely up there.
Yeah,
Probably responsible for, like, half of all developer frustration, I'd guess.
totally. But look, if you're aiming to really master that objects, functions, and classes domain for, technical interviews or exams.
Which is the big chunk, right? Like
What?
25%.
Exactly. So understanding this isn't optional. You've got to get it.
Mm-hmm.
Our goal today, try and boil it down. Get to that one simple rule. The value of this. It really just depends on how the function is called.
Okay, so to set the stage, we need to talk about function types first.
Mm-hmm.
Because how they handle this and hoisting, it differs.
Right.
You've got your classic function declarations like function myfunc. They get fully hoisted.
Okay, hoisted. Got it.
Then function expressions, maybe const myfunc function. Those act like variables, so they're not hoisted in the same way.
Not hoisted. Okay.
And then the newer kid on the block,
Yeah.
arrow functions,
Yeah.
block scoped. And they have a totally special rule for this.
So let's unpack those first two, the dynamic ones, declarations and expressions. You said this is dynamic there.
Yeah, dynamic meaning it changes based on how you run the function.
So what's the most common way that this gets set?
That would be implicit binding. It sounds fancy, but it's just when you call a function as a method on an object.
Like user.greet.
Exactly like user.greet. In that specific call, JavaScript automatically says, okay, inside greet, this refers to user. Simple as that.
Seems simple enough,
But yeah, here's the catch. What if you, say, assign user.greet to another variable? Let's call it say hello user.greet.
Okay.
And then you just call say hello directly without the user part.
It's not attached to user anymore when you call it that way.
Precisely. It loses that implicit context. And in strict mode, which you should be using, this inside say hello will default to undefined. Boom. Error.
Okay, that makes sense why people get confused.
Yeah.
So that leads us to forcing the context, explicit binding.
Yep, that's your manual override using methods like call, apply, or bind.
Right. Now, call and apply, they run the function immediately, just with a different this, right?
Immediately. You give them this value, any arguments, and bam, the function executes then and there.
But bind is different. What's the key distinction there?
Bind is the persistent one. When you use bind do this, it doesn't actually run the function.
Oh, okay.
Instead, it returns a completely new function, a copy, sort of.
A copy where this is locked.
Exactly. This is permanently bound to whatever object you passed into bind.
Yeah.
That new function will always have this context no matter how or where you call it later. Super useful for callbacks or event handlers.
So bind is like a permanent fix for a standard function's dynamic nature. But what if we didn't want to fix it after the fact? What if we wanted something structurally different?
Well, that's where arrow functions really change the game.
The lexical fix, right.
Arrow functions basically say, I don't want my own this context, thank you very much. They just don't have one.
So what do they use then?
They use lexical scoping, which just means they look outside themselves to the code that physically surrounds them where they were written.
Not where they're called, but where they're defined.
Exactly. They inherit this value from their parent scope, the surrounding function or global scope. It's determined when you write the code, not when you run it.
Okay. The arrow function doesn't have its own this.
Correct. So it looks outwards. Where was it written? Inside the start method. What was this inside the start method?
It was the timer object.
Exactly. So the arrow function borrows the timer object's this. And when it runs later inside set timeout, it still remembers that this refers to timer, and this seconds correctly logs 30.
And you can't even mess it up with call, apply, or bind.
Nope. That lexical this in an arrow function is fixed. You can't change it with explicit binding methods. It ignores them for this.
Okay, so let's boil this down for everyone listening. Two core takeaways seem clear. Standard functions, declarations, and expressions have a dynamic this. It depends entirely on how you call them. Object method, this is the object. Called alone, this is likely undefined.
Right, dynamic context.
But arrow functions, they have lexical this. They inherit this from their parent scope where they were defined, and that's that. It doesn't change.
Lexical context, fixed. That's the fundamental difference.
Makes sense.
But, getting a handle on function binding in context, that's really just step one. Here's something to think about. How do these rules, dynamic this, lexical this, then interact when you start layering on more complex concepts?
Like what?
Classes, prototypes, and inheritance. Because understanding how this behaves within those structures where context can be passed down or overridden in specific ways, that's where the real mastery of this domain comes into play. That interaction is the next level.